Hi, so in today's lesson, we're going to be talking about the laws of indices. But before we dive into the law of indices, let me just give you an understanding about indices before we go. So, indices is actually a plural word of the word index. So, index, another word for index is the word power. So, we have the word raised to the powers of a particular number. Or sometimes some textbooks use exponent. Then, index power exponent. So, and it's actually a short form for writing the product of a number that are the same. Product of numbers that are the same. Let's say, for example, 2 multiplied by 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 2. I'm going to continue to write that. So, equals to. So the short form of writing all of this is actually to write all of them at the same 2 to the power of how many are they? 1, 2, 3, 4, 5, 6. So I'm going to write that 6 at the top. So that 6 I have written at the top. So this 6 that I wrote here is actually called the index. So this is called index. Or sometimes some textbook call that exponent. Some textbook also will call that power raised to the power of 6. Then this 2 here is called the base. So it's the base number. So that's the base. So we have 2 raised to the power of 6. 6 is the index, or you can call it the exponent or the power, while 2 is the base. So now let's dive into the law. So the first law we're going to be talking about is the multiplication law. The multiplication law. Okay, so and that is generally given as a raised to the power of x multiplied by a raised to the power of y. So what they are saying that if you have a common base, if you have numbers that have the same base but the power might be different, a to the power of x multiplied by a to the power of y. So that can be written as a raised to the power of x plus y. So that's the rule. That's the law. Let me give you an example. Let's say 2 to the power of 2 multiplied by 2 to the power of 3. Now, mind you, they have the same base, so the law only agrees or is only applied when the base are the same. So since both of them have the same base, then common base 2, then 2 by 3 that you're going to have the power, you're going to add up the power, 2 plus 3, and then I go with 2 raised to the power of 5. And 2 raised to the power of 5 is 32. Or what about if I have 5 to the power of x multiplied by 5 to the power of y? I would get 5 to the power of x plus y. They have common base. Right, good. What about if I have 3 3 to the power of 15 multiplied by 3 to the power of 2. I'm going to have, since they have the same common base, 3, but I have 3, that's 15 plus 2. And so definitely I have 3 to the power of 17. Okay. So what about if I have what about if I have 3 to the power of 2 multiplied by 2 to the power of 3? Now, I can't apply the multiplication law. Why? Because the base are not the same. So this would not follow the law of multiplication and law of indices. So know that. So there we go with the division law. The division law. And the general rule for that is a to the power of x divided by a to the power of y is equal to a to the power of x minus y. So that means this rule only holds when the base are the same. Then if it's a divide, then you have to subtract the base, the index from each other. Let's take an example. So you have 5 raised to the power of 3 divided by 5 raised to the power of, okay, just 5. So we're going to have 5 to the power of 3 divided by 5 to the power of, for 5 to the power of 1 is actually 5. So, and I have 5 to the power of, from law of indices, the bases are the same. So I'll just subtract the power from each other. So I have 3 minus 1, and I have 5 to the power of 2, and I have 25. Alright, so I could take another example by saying 3 to the power of 7 divided by 3 to the power of 2. And then, because the bases are actually the same, I'm going to have 3 to the power of 7, law of indices, division law, minus 2, and I have 3 to the power of 5. So here we have the power law. And what does the power law looks like? So that's say if A is raised to the power of x, then now raised to the power of y, then A is raised to the power of x multiplied by y. That is the law. So let's take an example. So if you have 3 squared all raised to the power of 3. So basically, that is saying 3 squared, that's 3 raised to the power of 2, according to this law, multiplied by 3. And that's 3 to the power of 6. Or what about 5 raised to the power of 3 all raised to the power of 5? That will be 5 to the power of 3 multiplied by 5, and that will give us 5 to the power of 15. 3 times 5. So that's a power law, basically. Alright, the product power law. Now do we do that? The product power law is actually says that if A, B, all raised to the power of x, then that is must be equals to A raised to the power of x multiplied by B multiplied by B raised to the power of x. So let me take an example to actually make you understand this properly. So let's say 3y all raised to the power of 2. So basically, what that law is saying that will have to be 3 raised to the power of 2 multiplied by y raised to the power of 2. And that has to be 9 squared, 9y squared. And let's take another example. 2xy all raised to the power of 5. So that has to be 2. So everything inside this bracket will be raised to the power of 5. That's what that means. So 2 raised to the power of 5 multiplied by x to the power of 5 multiplied by y to the power of 5. And so that gives us 2 raised to the power of 5 is 32, x raised to the power of 5, y raised to the power of 5. Now I want you to note something, that 3y squared is not the same as 3y all squared. Why? Because this is 3y squared and this would be 3 squared y squared, and that would be 9y squared. So they are different. It's never the same with this. So don't confuse this with this. Then you have the zero index. And what does the zero index law says? It says that if any number is raised to the power of 0, then that number must be equal to 1. So e.g., 5 raised to the power 3 divided by 5 raised to the power of 3. So from our knowledge about the law of division, the division law, that will be 5, since their bases are the same, that will be 5, then division becomes minus. And so you have 5 raised to the power of 0. And from the law of zero index, anything raised to the power of 0 is equal to 1. So 5 raised to the power of 0 is definitely 1. Let's take another example. 2 to the power of 5 divided by 2 to the power of 5. Now their bases are the same, so that establishes that law, and that will be 5 minus 5, and that becomes 2 raised to the power of 0. And from the law of zero index, anything raised to the power of 0 is equal to 1. So that's that. So we're looking at the negative index law. Negative index law. So how does that look like? It says that if a number is raised to the power of negative number, then there has to be 1 over a raised to the power of x. So how does that relate? Let's take an example. So let's have 4 to the power of minus, let's have 4 raised to the power of minus 1 over 2. Okay, good. So that will be 1 over 4 raised to the power of 1 over 2. So that means that negative, that minus, is becoming 1 over. That's what that means. And that becomes 4 raised to the power of half is actually 2. Let's take an example. Let's say 33 raised to the power of minus 3 over 5. So basically that minus, this guy here, minus, will become 1 over, then you have 33 raised to the power of 3 over 5. Let's take another example. Let's say you have az. Let's say you have az all raised to the power of minus 1 over 5. Now, this negative number has has to become 1 over, then you have a z all raised to the power of 1 over 5. So that's how the negative index law is put into practice. So here we have the root power. And what does it say? Say that a raised to the power of 1 over any number is actually equals to the nth root of that. So you have a raised to the power 1 over n equals to nth root of a. And how does that play? So let's say we have 4 raised to the power of half. So basically that's going to be 2, 4. So basically we don't even write the 2 when you write the square root. You just basically write square root of 4. And that gives us 2. But if you have 9 to the power of half, that basically gives you 2 then 9. So square root of 9, we just write that square root of 9 and that gives us 3. What about if you have 27 to the power of 1 over 3? And that's going to be the root, the denominator of the fraction is going to be outside of the root, and the original number is going to be inside the root, and that's third root of 27. So type by a calculator, what's third root of 27? That gives us 3. So 3 times 3 times 3 gives us 27. So here we have the fractional index. And how do we deal with this? So it says that a raised to the power of x over y is actually equal to the white root of a all raised to the power of x. So let's take an example. Let's say 4 raised to the power of 3 over 2. Now from the law, you know that the y, that's the base, the denominator of the fraction, became the root. So that will be square root, that's 2 into 4. Then the numerator now is now all raised to the power of 3. And that's square root of 4 all raised to the power of 3. And that's 2 raised to the power of 3. And that's 8. Let's take another example. 4 to the power of 5 over 2. So that one becomes 2 into 4 all raised to the power of 5. So it's the denominator of the fraction that becomes the root. So you have square root of 4 is 2 raised to the power of 5, and that's 32. Then let's take another example. 8 raised to the power of 4 over 3. So the denominator of this fraction is 3. So that will be the root, third root of this 8. Then all raised to the power of the numerator of the fraction, that's 4. And that becomes third root of 8 is actually 2 raised to the power of 4. And 2 raised to the power of 4 is 16.